Hey guys, welcome back. This is Metric Prefixes by Anandu Mahesh. Start off with a quick joke. This man states that this is the metric system. It is simpler, easier, and the entire world uses it. Unfortunately, he's incorrect, and the United States does not use this. Everyone else, every other country uses this except for the United States. We use the imperial system, which I believe we should switch, but others don't think so. Some basic SI prefixes we'll be talking about today are kilo, centi, milli, micro, and nano. We'll go into depth later on in this video, but these are the basic raw values that you need to know. So kilo would be 1,000 for every, it'd be like, how many kilos would be in 1 gram? It'd be 0.001 because there's this many grams in 1 kilo. So centi would be 0.01, milli 0.01, micro 0.000001. This is also 1 millionth. Nano is 1 billionth. So let's look at the symbols real quick, and there's one oddball out. I'll talk about that soon. Kilo is denoted by K. It's pretty easy to remember. Centi is with C. Milli is with M. And we'll skip micro for a second. And nano is for N. So micro has a weird symbol. This is called mu. It's a Greek letter, and it denotes micro. So these prefixes go before a unit. And remember, these prefixes apply to any unit. Grams, meters, seconds, whatever it is, it applies to. So for example, kilo, meters, kilometers. It would be km, kilometers, meters, right? And so centimeters, it would be cm. Milliliters, ml. So let's take a look at some of the other prefixes that we have. We have deca, hecto, kilo, mega, giga. And it goes all the way up. It goes all the way up to septillion. That's ridiculously high. 10 to the 24th. So deca would be 10. Hecto would be 100. For example, hecto could be like hectare. If you've ever heard of a hectare, it would be 100 acres. Hectare, is it hectare, hectare? It's one of those two, but it's 100, 10 squared. Kilo is 10 cubed, 1,000. As we talked about before, mega is 10 to the 6th, which would be a million. Giga is 10 to the 9th, 1 billion. And if we notice a pattern here, every time we're going up, there's an increment of 3 for this factor. So it'd be 10 to the 3rd to 10 to the 6th. We're increasing by 3 zeros, 3 values, or place values. 10 to the 9th, you're increasing by 3 again, all the way up, and we can keep going all the way up to a septillion. Some values that are less than 1, decimal wise, would be deci, and if it's less than 1, if it's a 0 point something value, it would be a negative exponent. It would be 10 to the negative 1. So if we write 1, and if it's 10 to the negative 1, you draw the point, the decimal, and have 1 0 after the decimal. Here it would be 10 to the negative 2. Be 1, 2 zeros. So basically all we did was, after this is negative 1, that's how many spaces it is to the 1. So it'd be 1, 1, 2, 1. Let's put this pointer on so you can see better. So you're going 1. That's 10 to the negative 1. From here, you're going 1, 2, negative 2. 1, 2, 3. 10 to the negative 3. So, and all we have to add to the end would be a th to make it less than 1. So it'd be 100th, 1,000th, millionth, billionth, trillionth, quadrillionth, quintillionth. Let's do this blank right here real quick. So if this is 10 to the 15, negative 15, and this is 10 to the negative 18th, we'll have 3 additional values, right? So this would be 0.000000000000000000001. I can't say Z's anymore. Alright, so that's the value for quintillionth. If it was quintillion, I'm not saying that number, sorry, it's too long. So sextillionth is this value right here, and septillionth would be the next value. As we looked at it in the previous slide, it goes quintillion, sextillion, septillion. So this one would be septillionth, the TH at the end. Some examples would be meters to centimeters.
It's 10 o'clock.
Okay, thank you. So if we were converting from meters to centimeters, 1 centimeter is 1,000th meter. No, sorry, 100th of a meter, right? So if we look at this, we can do some conversion real quick. If 1 centimeter is 0.01 meters, if we multiply this by 100, we'll get 1. But whatever you do to one side, you have to do the other. So 1 meter will equal to 100 centimeters. So apply the same logic here. 1 gram is 1,000th kilograms. So multiply by 1,000 on both sides, and we get kilogram is 1,000 grams. Second to microseconds, micro is 10 to the negative 6th, which is 1 millionth. And so there would be 1 million microseconds in 1 second. Liters is 1,000, same logic, same thing. So let's try this problem real quick. Convert 6,000 grams to kilograms. Remember, 1 kilogram is equal to 1,000 grams. So let's do this, set up the equation. It would be 6,000 grams. That's what we're given. And we know that 1 kilogram has 1,000 grams. So for every 1,000 grams, there's 1 kilogram. And when we divide this, we'll get 6,000 grams divided by 1,000 grams. The grams will divide out, leaving us with 6,000 divided by 1,000, which is 6 grams. So we can double check this by dividing by 0.0001, 0.0001 1,000th to get the value back into grams to double check. And surely enough, we'll get 6,000 grams when we do that. And hope this video helped. Thank you for watching.